Welcome to BCIS 1305. This is Dr. Schuessler again, and today we're going to be talking about operating systems, chapter 9. So let's go ahead and dive on in and talk a little bit about operating systems. So start out, we'll define what an operating system is. We've talked about this earlier in the semester, but in this chapter we're going to dive into a little bit more detail. We'll talk about the startup process, the shutdown options that computers and mobile devices have, and when you might want to choose one over the other. We'll talk about an operating system and how it provides a user interface, manages programs, manages memories, coordinates tasks, and stuff like that. We'll describe how an operating system enables users to configure devices and works with device drivers and stuff like that. We'll talk about file management. This is an area that students typically are horrible at. Having said that, I'm horrible at it myself. But we need to do a better job of file management, and operating systems allow us to do that. They give us the tools to do that with. So we'll talk a little bit about that. We'll explain how an operating system enables users to control a network or administer security. We'll summarize the features of several desktop operating systems. We're going to talk briefly about some of the different types of operating systems. And we'll talk about some of the features and uses of mobile, some of the mobile operating systems. And then I'll finish the discussion briefly, just kind of sharing with you a few different operating systems that I play with periodically. Okay, so an operating system is a set of programs containing instructions that work together to coordinate all the activities among computer and mobile device hardware. So these are some of the different things that an operating system does. It helps you to manage memory. It helps you to configure devices. It helps you to control a network, administer security, provides a user interface. There's really kind of two parts to the operating system. There's the kernel portion of the operating system, which is the real core of the operating system itself. It's the part that's really required and really does the interaction at a very low level with the hardware. Then we have various utility programs that tend to get piled on top of the kernel that really are more user-facing, allow us to directly interact with the operating system. So allows you to create files, delete files, move files, shut the computer down, start the computer up, all those types of things. So this is kind of a graphical representation of the previous slide. I'm not going to really go into it, but they're trying to represent here, creating users and monitoring network performance and so on. What happens when we actually turn the computer on, when we actually hit that power button on the computer itself? It starts to power up and it goes through what's referred to as a post-test, P-O-S-T, power on self-test. And this is basically a brief little diagnostic program that's loaded from the firmware on the computer that runs through a series of checks to make sure that the memory it exists on the system, that it's installed properly, that the CPU is detected, that your various peripheral components are detected, such as your mouse and your keyboard and your monitor, all those types of things. And if everything is okay, it looks for a boot device. And usually that boot device is going to be your hard disk, though it can be other devices such as a USB drive, or it can boot off the network, for example. It can boot off of a CD-ROM, DVD disk. But usually it's going to be the hard disk on your laptop or on your desktop computer system. So once it finds the boot device, it's going to load that operating system into memory. And that's where your operating system is going to reside while you're using it, while you're using your system. It resides in memory and allows you to open and close programs and interact with your system that way. When it comes to shutting your system down, you've got a couple of different options, and I have to be honest with you, I'm not a big fan of either one of these, and I brought this up in class because in my opinion, you should shut your computer down periodically, and it allows an opportunity for your memory to be completely cleared out. A good behaving program, or a well-behaving program, when it shuts down, is supposed to remove all of its components from memory, and it frees up that space in memory for other files to be opened, for other programs to be run, things of that nature. Unfortunately, not all programs are written equally, or they don't all necessarily behave well. And so often what will happen is when you shut a program down or you close a file, it will remove most of what's associated with that program or file, but not necessarily everything. And so the only way to really kind of clean that out is through a good reboot. These kind of bypass that process, and so I'm not a big fan of either one of these, but I will briefly mention the differences between the two. Sleep mode saves any open documents, running programs, or apps into memory, and then turns off needed functions, so it reduces the power consumption of the system considerably. And this allows you, because it's still in memory, just running at a very slow state, it allows you to return back to where you were very quickly, very same place you were very quickly, because everything's still in memory. Now the downside is if you lose power, if you're in a laptop and the battery comes out, or you're working on your system and you pop the memory out, you're going to create problems for yourself. So I don't like that approach. Hibernate is something very similar, except that instead of keeping it in memory, it saves the state that you're in, whatever programs you have open and files you have open, it saves that state back to the hard drive. So the speed is not so much, it's not necessarily the same, a speed enhancement in terms of being able to return back to where you were very quickly like sleep mode is, but it does allow you to return to the exact same state that you were in. So those files that you had open, anything that you had open, it returns you back to that same state. So that's the advantage to that. But you don't have the speed performance that you would have like you do with sleep mode. Again, I'm not a big fan of either one of these. I think you should reboot your system pretty regularly. Now, the way we interact with the operating system is through a user interface, and most of us anymore are very familiar with a graphical user interface, or a GUI, and that's the one that we typically see in Windows and Mac, and even in most of the flavors of Linux anymore. We see the GUI that we interact with, and it shows us icons, it shows us windows, and all those kinds of things in a graphical way, and it's very easy to interpret, very user-friendly, and this is certainly much of the appeal for this type of environment. This is as opposed to the command line interface, which is something we've traditionally had. In this particular case, this is an example of a Linux command shell, or perhaps Unix, and this is what allows us to start files, to look at the files that we have. You can probably tell this is pretty cumbersome relative to the graphical user interface. A command line interface, you really have to learn how to navigate directories, to identify executable files, and type in the commands to be able to run a file or to be able to do things. And so the experience is significantly different, and the experience levels of users is significantly different as well. In a command line environment, users really need to have much greater knowledge about what's going on the computer system than they do in a graphical user environment. When we talk about some of the different operating system functions, we can kind of think of some of those functions in these three different ways, and this really affects how productive you can be as a user. The operating system can either be working on a single task at a time, or it can multitask. It can work on multiple tasks at a time. In a single task environment, we're really only able to do one thing at a time. We can work on a particular program, we can work on a particular file, and if we need to work on a different file, we have to close the file that we're working on down to be able to make room, make space for the new one that we're going to work on. So you can see where this really kind of impacts your productivity. You can do one thing at a time. You've got to shut everything down and go to the next one to be able to do something else. If you have to switch back and forth a lot, this can be pretty tedious. This is as opposed to multitasking, which you often see in a graphical environment. It allows you to have multiple windows open, doing multiple things at the same time. This leads us to the next concept of foreground and background. The next slide kind of tries to give you a graphical representation of this. But the foreground is the application, the program that you're working on at that specific moment in time. But that doesn't mean that you can't have other things going on in the background. These are background applications that are potentially still continuing to process and do things while you work in the foreground, but they're given less priority because you're not actively working on them. You've also got single user and multi-user environments. Most of the time, command line systems are going to be single user, and a lot of the graphical environments allow multi-users. This isn't always the case. For example, Unix and Linux do allow multiple users to be logged into the system simultaneously, but DOS, for example, doesn't. So it's a difference between the different types of command line operating systems. So here's kind of that graphical representation of background and foreground applications. You may be working on this graphic here in this front window here, but you may have other windows that are open in the background that you might have been doing things on. If we were in a single user environment or an environment where you couldn't, where you could only work on a single task at a time, if you were working on this right here and you needed to switch over to the calendar, for example, to put a date in here, and you need to look up that date. If we were in an environment where we could only work on one thing at a time, we'd have to close this down, switch over to our calendar, open it up, look up the date, note the date, either mentally or write it down on a piece of paper, close it down, go back to our graphic, open it back up, and then we could insert the date. Obviously, that's very tedious. It's a lot more difficult to just close one, open one, and go back and forth that way. It's a lot easier to have multiple windows open at the same time. So multitasking was a big jump forward. Now, to be able to multitask, we have to be able to open multiple things at the same time. We started out the discussion of operating systems talking about when we boot a device, the first thing it does is it goes through that power on self-test, and then it loads the operating system into memory. In the text, it gives you a nice little graphic of what your memory might look up as it starts to fill up. So that operating system is taking up space in memory. As we fire up the applications that we were just looking at, that takes up more and more memory. So as we fill up our memory, eventually we get to the point to where memory is full. Well, depending on the operating system, it may, it's going to handle it in different ways. Some may not allow you to open up any more files or start any more applications. That's how it helps to protect itself and not run out of memory. Most modern operating systems, however, use a concept known as virtual memory. And this is basically the idea that when our memory fills up, we're going to borrow space from our hard disk. So we're going to open up a space, a swap file of some sort, on our hard disk, and this is a reserved part that we're going to use for programs and files that we know we're going to need shortly, but we didn't have space for in memory. When we need them, we'll go retrieve, we'll send something from memory to our swap file to make space, and then retrieve what we need from our swap file into memory so that we can work on it. A lot of times, what we should have gotten from last week's discussion of hardware and hard disk specifically is we know that from a performance perspective, hard disks don't function as fast as memory. So if we're utilizing virtual memory a lot, we're going to see the performance of our system go down because that hard disk doesn't respond as much. This can be an indication that maybe we need to increase the amount of memory that we have on a system to increase our performance. But we have to look at the performance monitor to be able to make that determination. Another function that the operating system does is to manage the tasks that our system has before it. As a user, we implement various things, we start various things, and it's the operating system's job to keep track of all those tasks and place priorities on those tasks. So you can kind of relate it to when you send multiple print jobs to a printer. But the operating system's job is to make sure that one print job is handled, it's completed before the next print job is started and completed. Otherwise, you might end up with different print jobs getting intermingled between each other, and you have different pages for different print jobs being printed together, printed back to back, and so you end up with a mess. It's the operating system's job to make sure that that doesn't happen. Another function that the operating system deals with are drivers. Drivers are basically small little programs that act as an interface between the operating system and hardware that you install on a system. So if you load a new graphics card or a new network card, or you plug up a new printer, You need some sort of a program that tells the operating system this is how you can communicate with that particular device. And that's the purpose behind a driver. That's what a driver does. Plug and play is a concept that really kind of came to us from the mid-90s, Windows 95, and it is a concept that basically prompts the operating system to try to configure new devices as you install them. And depending on the devices, how common the device is that we're plugging up, in a lot of cases, plug and play works quite well. In other cases, you really kind of have to manually go through some of those processes. But it's an attempt to kind of automatically install some of those drivers for you and reduce the need for user interaction that you used to have. Another operating system function is to help set up internet connections. And so you see a couple of examples here of what you might see on a Windows machine and on a mobile iOS device, probably an iPhone or an iTouch or something like that. So it allows you to set it up, type in your codes, your security codes to be able to access networks, things like that. Another function that operating systems allow is to monitor the performance of your system. Monitoring the performance of your system is usually something that's not done until there's a problem, unfortunately. Really, to make a performance monitor operation much more productive, you really need to do it during a normal state first. And this is referred to as baselining. And this gives you an idea of how your system's performing. How fast is your processor working? How much memory is being used? How fast is your hard disk responding? How much network performance is being done? Things like that. If you don't do that baseline, then when you do have a problem, you don't have anything to compare your performance monitor to normal operations. But that's kind of the idea behind a performance monitor. It allows you to assess how your system is functioning. Other operating system functions include a variety of different little programs that interact and allow you to interact, kind of maintain the state of your operating system and take care of it. For example, you can manage files. You can create folders, rename files, create new files, things like that, directly through the file manager. And this is a kind of a lost skill with students. And not just students, other people do it as well. I know myself, I'm horrible about it. I have files all over my desktop. I do a really lousy job of file management. But we need to be better at this. This is what allows us to do a better job of backing up our files. If we have files everywhere on our system, invariably we're going to end up missing a few files that we really need. We're not going to back up the files that we specifically need. We can't keep track of them. We lose files, things like that. There's the most systems have some sort of uninstaller process, and this is something I talked about in class as well. Apple does a better job when it comes to installing programs and getting rid of programs. You simply delete the program and it's gone. In a Windows environment, when you go to install a program, it creates a folder for a lot of the files that program needs, but it also makes modifications to other system files throughout the system. So if you simply delete that folder, you're getting rid of a big chunk of that program, but you're not getting rid of those changes that were made to those various system files. So you need to go through that uninstall process by using the uninstaller that's built into Windows. You've also got disk cleanup, disk defragmenter, screensavers, file compression, all kinds of stuff. Absolutely get familiar with most of these. Disk defragmentation is not something that's as necessary as it once was, as Windows does a much better job of trying to make sure files don't become fragmented. But at the same time, periodically, you do need to run disk defragmenter. We talked about this in class that last week when we were talking about hard disks and the idea of different tracks and sectors and things like that on the hard disk, that files that span multiple sectors, oftentimes as the hard disk begins to fill up, a single file will be placed in different sectors that aren't necessarily right next to each other. So those files are becoming fragmented. And so it takes a little bit longer to be able to access that file. We have to wait for the disk to spin around to get to the next sector that we need. We have to wait for the head to spin across the platter to get to the next track that we need. So that becomes an issue. A disk defragmenting program puts those files back together and helps to speed up the performance of our system. In class, I also mentioned about file compression. I'm not a big fan of it. I think the price of hard disks is low enough. If you feel like you need to compress your hard disk, get a bigger hard disk. Compression slows your system down because as you go to save a file, it has to be compressed to be put on the disk. When you go to use that file, it has to be uncompressed so it can be loaded into memory so you can use it. So file compression to me is a last resort approach. And then backup and restore, it's always an absolute necessary evil. Nobody does it the way they should, or as much as they should, or at least very few people do. That's why I'm such a big proponent of cloud storage. But be aware that those are tools that you have at your disposal in most operating systems. Automatic updates. This is another thing we discussed in class. Most people are pretty bad about this. They like to hit cancel because they don't want to tie up system resources. They're in the middle of working on a paper or typing up an email or something like that. Set automatic updates on your operating system and allow it to do those updates. The vast majority of security breaches are situations in which a patch has already been released. So if you allow those automatic updates to occur as those updates come out, you'll tend to be much more secure than you would otherwise be. Other operating systems, system functions. Some operating systems are designed to work with a server on a network. This is a client-server environment. The reality is any device on a network can be a server. Any device on a network can be a client. The idea is not so much the type of operating system or the specific operating system that we have, but rather what you're doing with it. So if you're sharing a file from Windows XP or Windows 7, for example, you're serving up that file. You're serving up that share to other computers. So if you're on Windows 7 and you're sharing a file with a Windows Server 2012 machine, the server in that relationship is a client. The Windows 7 machine is the server. In a networked environment with network operating systems, you'll have a network administrator, and their job is to manage that server, and they've got various roles that they need to handle. They'll need to add users, add and remove users, things like that. They'll configure network devices, network software, things like that. If we're in that type of environment, if we're administering a network or if we're administering an individual machine, it becomes our responsibility to manage users on that machine or on that network. And we're going to do so by creating usernames and passwords. And we talked about in class, make sure you've got a long password, something that's not easily guessed and things like that. But that becomes your role as a network administrator or as a system administrator, is to create that and manage those user accounts. In general, we can break up operating systems into three general classes. There's probably several different ways to slice and dice operating systems, but this is probably as good as any. We can throw operating systems into the desktop categories, we can throw them into server categories, and we can throw them into mobile device categories. One of the things you should notice here is there's some decent overlap when we talk about desktops and servers. So for example, we see Linux and Unix as a desktop, but we also see it down here as a server. The reality is your Windows could be down here as well. We've got Windows Server, but you could also have Windows 7 or Windows XP or Windows 8 in a server, acting as a server as well. So those are kind of some general, kind of a general classification of some of those different OSs. So at the desktop level, we've got Windows, Mac OS, Unix, Linux, and Chrome OS. And these are ones that are really designed for the vast majority of users. We're used to how they work. We're comfortable with them. Most, if not all, are available with graphical user interfaces. Pretty easy to work with. Windows 8, for example, gives you a variety of features, and most of these features are going to be available in some way, shape, or form on the other systems as well. They may have their own terminology and their own names, but they're going to be very graphical. They're going to be designed for desktops. They're going to support, in a lot of cases, touch. as well as a mouse and a keyboard. They're going to have built-in applications, including web browsers and email applications and stuff like that. In a lot of cases, there's integration with web services and photo things online, all that kind of stuff. With Windows 8, obviously, that's SkyDrive, but with Google, for example, obviously, it's Google Drive. Security, we're getting much better about, especially in terms of firewalls, automatic updates, and antivirus programs. But most of these platforms are going to have all those available for them. And then there's usually some kind of tie-in with some sort of store, whether it's Windows or it's Apple or it's Google. They all have their own stores where they sell applications, where they sell or apps, where they sell files, whether it be music or video, things like that. So lots and lots of similarity, regardless of the OS that you're dealing with. So this is what Windows 8 looks like, and most of you have probably seen this, various tiles that you see and you can interact with that way. A little bit of a stretch from the more traditional Windows OSs that you've seen in the past. Mac OS, the Macintosh operating system, very easy to use, very user-friendly, very intuitive, been around for quite some time at this point, and most people are very familiar with how it works. I'm not a big Mac person myself, but those that use it are really tend to swear by it and really like it a lot. A lot of the concepts that you see in some of the Windows operating systems come to us from Linux, come to us from Mac, so something to kind of be aware of. Other desktop operating systems, Unix and Linux. Unix is typically seen as a server operating system. It's been around for a very long time, since the 70s, where it was command line oriented. But more recently, there have been graphical user interfaces placed on top of that, so it becomes much easier to use. And so as a result, you start to see Unix slide into the desktop operating system market. Same thing with Linux. Started out command line oriented, much newer than Unix, though it has a very, very, very similar look and feel to it, especially in the command line environment, but now has a GUI that's on top of it and allows you to really kind of configure it in a lot of ways to look a lot like Windows. Chrome OS, Linux, another Linux-based operating system designed to work primarily with web apps. A lot of integration with the internet and applications that run across the internet from Google servers. I really like this, again, because you're storing so much in the cloud. As long as you've got good internet connectivity, this is a good way to go. You don't have that issue of having files all over your desktop, of having to back up your system and all that kind of stuff. A lot of that's handled for you by people that's really kind of their job. So it's a good approach, if you ask me. When it comes to server operating systems, there's a little bit less variety. Windows Server is a big player in this market, as is Unix and Linux. Unix really was kind of the operating system of choice in the early days of the internet, and so that's kind of led to the prominence of Linux being widely used as well. Windows, because of the popularity of their desktop operating system, has become a big player in the server environment. OS X servers trying to make a niche for themselves, and perhaps they'll get there someday. Those are your big players when it comes to server operating systems. As for mobile operating systems, you got Android, iOS, and Windows Phone. And in this market, it's really more about Android and iOS. Windows is trying to make inroads there. They've purchased cell phone companies, for example, trying to make a bigger impact, but they're struggling in that market. Having said that, it's a nice little OS. It has a lot of similarities to their desktop operating systems, which is nice, but they just haven't been able to crack the Android and iOS market yet. Android's an open source Linux-based mobile operating system designed for Google, designed by Google for smartphones and tablets. I've got a little Google Nexus tablet. I really like it. A lot of tight integration with their web apps, their phones, all those types of things. So when you create a file in one, you see it everywhere, and it's just really a nice, slick operating system. In class, we talked about kind of the distinction between their model versus the Apple model. And in the Android model, it's a very open model which gives you both pros and cons. Pros being much more opportunity for creativity on the part of developers to create all kinds of apps and have a lot more variety and stuff like that. That's a very positive model. The downside is because of that, you tend to be subject much more to security issues, and that's a pretty big downside, so be aware of that. This is as opposed to the iOS model, which is a closed system. So everything runs through, unless you jailbreak your Apple device, everything goes through Apple. And again, like everything, there's pros and cons to it. The pros being, it tends to be a more secure environment because it has to go through Apple. Apple vets applications as they're developed and submitted to them. And so they make determinations. Is this a good one? Is this something our users will like? Is this going to be a security risk? Things like that. And then they make that determination. The downside is it kind of stifles innovation. So we're going to have, in the long run, you're going to see less and less creativity from that type of model. But that's what the iOS approach is, or Apple's approach with iOS is. And it's a very nice, user-friendly environment. Again, very similar, and you go from one device to the next, whether it's an iPhone or tablet, etc. And then the Windows Phone. Again, if you're used to Windows 8, you've seen those tiles. You see the tiles in their Windows Phone as well. People that like it really kind of like. They really kind of feel like it's very innovative and things like that, or not innovative, very intuitive, and so it can be pretty nice. I kind of like it. I have an iPhone. I don't have a Windows Phone, but I really kind of like the environment that you see here. Having said that, my next phone would probably be an Android device. So in this chapter, we talked about some of the common functions to most operating systems. Most operating systems are going to give you a lot of the same functionality. They may call it something different from one device to the next, or from one OS to the next, but in most cases, the same kind of functionality is going to be available on the different operating systems. We also talked about some of the different types of desktop operating systems, server operating systems, and mobile operating systems, and what some of the different options were within those categories. So that is that chapter in a nutshell. Before we finish up, I did want to switch over real quick and kind of introduce you just briefly to some of the other operating systems that are out there. And I apologize for the screen resolution, but I'm remoting in to a Hyper-V session on my server, and then within that, looking at some of the virtual machines. So this is Kali Linux, and you'll see from this, you've got your desktop here, and let me scroll down here to the bottom so you can kind of see what the bottom looks like. So it doesn't quite look like Windows, but it is very graphical. You'll see different desktops that you can look at here. So kind of like what you start to see in Windows with different desktops that you can have. Applications, if you want to look at some of the different applications, you've got a lot of things that are there. For example, you've got your calculator. And so you'll see a lot of similarity that you have between Windows and Linux. There's a lot of different flavors of Linux, though, and these different flavors are created by different people, and they're designed around different things. For example, Kali Linux is really designed around security, with security considerations, to be able to test penetration testing and things like that. So that's kind of the idea behind it. But there's other versions that are designed to be really small and run from devices that don't have a lot of storage. Ones that are designed to be run from thumb drives, for example. So there's lots of different flavors of Linux. As you can see, this one is connected to the internet. I had my browser open there a minute ago. So there's the browser I had open, so you can access various things that way and look around, and that's pretty much Linux. There's lots of different flavors of Linux. I encourage you to consider downloading something like VirtualBox and using the DreamSpark subscription to download some of these operating systems and play around with them. They're, as far as Linux, those are freely available all over the place. as far as some of the Windows operating systems. You can get those through DreamSpark, or you can download some of their trial versions and play with them in those virtual environments, and it allows you to really kind of get a feel for how that operating system, how it works, how it feels, how it looks, and things like that. Okay, so there you can see I'm able to access the internet. You can look around, all that kind of stuff. So I like Linux. It's really a pretty cool operating system. Like I said, I would encourage you to play around with it and get familiar with it, especially if you're a CIS major. Good knowledge of Linux is a great asset to be able to add to your resume. So let's go ahead and shut Linux down there. Let's go take a look at some of the other operating systems here. I've got DOS running right here. Actually, just kind of show it to you. Let's go ahead and reset it and let it reboot. Kind of show you around real quickly. Okay. So there we have DOS that just booted up, and that's what our user interface looks like. So this is a command line interface. If we want to be able to run something, we kind of need to look around. Here's some of the stuff, some of the different programs we can see. For example, the different some of the different programs that are available. The EXEs, for example, we can run some of these. So let's go type in edit and pull up a text editor. There we go. Looks pretty cool, doesn't it? So if I hit the Alt key, that allows me to go through and select some of the different choices. I can type stuff. I can hit Alt and then arrow down. I can save this. I'd be saving it as a text file. Save as. So I can save this file and do stuff like that. As you can tell, not very user-friendly, not kind of stuff that you would really get excited about today. So I don't want to save that file. That's DOS in a nutshell. Again, not a big fan of DOS. I actually want to go ahead and shut that down. Now, something else we've got. This is the last one I wanted to take a look at, but we've got Windows 10. Now, this is a preview version, so let's take a look at that real quick. Again, the same kind of thing. How does it look? Pretty much the same. It's kind of a cross between Windows 8 and Windows 7 with some of the older ones. You see your taskbar down at the bottom, some of your basic programs. When you come over here and click on the Start button, you're going to see your more traditional navigation structure here. But over here, it's a little bit different. You see those tiles that you tend to be familiar with and are used to, and it's a pretty slick interface. I haven't played around with it an awful lot yet. I will say that the news loads pretty slowly, but it is interesting to look at the tiles and watch that function. So while that's working, switch over, we'll click on that. So you can see I'm connected to the internet in my virtual machine. So that's pretty slick. And let's go back and see if the news has finished loading yet. I tried to bring this up in class and it took quite a bit. Again, I haven't played around with Windows 10 a lot yet. It is a preview version, but again, much like the Linux stuff, I would encourage you to go out and download and install VirtualBox. Download these programs. Windows 10 is available in DreamSpark. I found it elsewhere on the internet. But I would encourage you to download these operating systems, install them as virtual machines, and play around with them. That's the best way to get familiar with them. So here you can see the news tile finally loaded, and you can kind of look around and play there. So that is our preview, our look at operating systems for this chapter, Chapter 9. If you have any questions, by all means, shoot me a message, send me an email. This is a pretty important chapter. It's also a pretty interesting chapter, at least I think it is. I like being able to look around and play with some of the different operating systems. If you have any more questions, like I said, send me a message, check out my website, follow me on Twitter, all that kind of stuff. And until next time, I'll talk to you later.